Imagine you are lost in the middle of the Antarctic Ocean, a place so cold that it is almost devoid of life as you know it. And then, in a moment of curiosity, you look down into the deep, dark water beneath your feet. You might think you would only see tiny creatures, a few schools of minuscule fish or drifting clouds of plankton. But no, what you see is entirely different. Sea spiders with leg spans longer than a bows are crawling slowly along the ocean floor. Jellyfish with tentacles longer than a whale are silently drifting by. And even ordinary fish have become unusually large. It is all real. And what is even more frightening is that, in such a harsh, freezing, and food-scarce environment, all creatures should theoretically shrink to survive. But here, they become giants. So what is really happening beneath this layer of frozen water? And why has evolution taken such a completely opposite direction? Polar gigantism. What you just heard is not a science fiction story, but a real phenomenon known as polar gigantism. This is one of the strangest evolutionary phenomena on Earth, yet very few people know about it because it only occurs in the coldest oceans on the planet. What makes this phenomenon so special is that it completely defies conventional survival logic. In a freezing environment where energy is scarce and living conditions are harsh, you would think that creatures must become smaller to conserve energy. But in Antarctica, the exact opposite happens. Creatures not only do not shrink, but they also develop into magnified versions of themselves. Originally tiny creatures become large, while already large creatures become unimaginably gigantic. This does not just happen to a few species, but spreads across almost the entire ecosystem beneath this freezing ocean. From sea spiders, starfish, and jellyfish to squid, all are caught up in a bizarre evolutionary rule that seemingly nowhere else on Earth can replicate. And the question is, why can this freezing environment alone create such a powerful effect? The Antarctic colossal squid. To better understand this phenomenon, let's start with one of the clearest examples, the Antarctic colossal squid. This creature is not only large, but also one of the heaviest invertebrates on Earth. Many people believe their gigantic size is due to living in the deep sea, but in reality, most of them live in the waters around Antarctica at near freezing temperatures. This very environment is the deciding factor. Originally, they belonged to the glass squid family, a group of creatures with nearly invisible bodies in the water. But as they evolved in the cold environment, they gradually abandoned that transparency to develop a thicker layer of flesh to retain heat. At the same time, their bodies turn dark red, which helps absorb light from bioluminescent prey instead of reflecting it, making them virtually invisible in the dark. Once they reached a gigantic size, they had few predators left, apart from a select few like whales, and that allowed them to shift their survival strategy from fleeing to ambushing. But even though all of this explains how they live, it still does not answer the most important question. Why did they become gigantic in the first place? The role of oxygen in cold water. The answer lies in the very aquatic environment they live in. Cold water can hold more oxygen than warm water, and this completely changes the biological limits of organisms. For most animals, the larger the body size, the higher the oxygen demand. In warm water environments, the amount of dissolved oxygen is not enough to support overly large bodies, so size is limited. But in an environment near 0 degrees, oxygen is so abundant that it is almost no longer a limiting factor. This is like breaking down a natural barrier that has existed for millions of years. When that barrier disappears, evolution begins to push species past their old limits, making them increasingly larger. Not only that, but a large body also helps store heat and energy better, which is extremely important in a freezing environment. Therefore, becoming gigantic is not only feasible, but also provides a clear survival advantage. Over millions of years, larger creatures will have a higher chance of survival, and gradually the entire ecosystem begins to shift toward a state of gigantism. Giant sea spiders. This effect does not only happen to squid, but is also clearly evident in smaller creatures like sea spiders. In warm waters, sea spiders are only about 1 to 2 centimeters in size, comparable to common house spiders. But when you find that same species in Antarctica, their size can reach over half a meter. What makes them special is how they breathe. Instead of having complex respiratory organs, they absorb oxygen directly through their legs. And as their legs grow longer, the amount of oxygen absorbed also increases significantly. This creates an evolutionary loop where a larger size allows for more oxygen absorption and more oxygen allows the size to continue increasing. Once they have become gigantic, they move across the ocean floor like slow machines, using their long, stilt-like legs to step over coral, starfish, and other creatures. When hunting, they use a straw-like structure to pierce their prey and suck out the insides, much like drinking a glass of milk. Remarkably, even their prey has become gigantic, creating an ecosystem where everything is larger than normal. Starfish and extreme evolution. If you think large size is the strangest thing, the starfish in Antarctica will make you change your mind. Not only are they larger, but they also develop in completely unusual ways. Instead of the usual 5 arms, some species can have over 50 arms. This is not just an exaggeration in size, but also a transformation in body structure. They are ferocious predators, even cannibalizing each other. Their lifespan also increases significantly, capable of living over 40 years, compared to only about 5 years in warm waters. This shows that the cold environment not only slows everything down, but also extends the life cycle, creating conditions for evolutionary changes to accumulate over time. The lion's mane jellyfish. The polar gigantism effect has also produced an astonishing record-holding creature, the lion's mane jellyfish, the longest creature ever recorded on Earth. Its tentacles can be longer than a blue whale, the largest creature on the planet. When compared to jellyfish of the same family living in warm waters, the difference is stark. Species in warm waters never reach this size, simply because their environment does not allow it. This once again proves that the cold environment not only supports, but also drives size development far beyond normal limits. Metabolism in a stable environment. In addition to high oxygen levels, low temperatures also slow down the metabolic process. This makes large bodies more energy efficient, as they consume less energy per unit of mass. At the same time, the cold ocean environment is extremely stable. The temperature barely changes, the pressure remains constant, and the number of predators is very low. There is no pressure forcing creatures to be fast, small, or agile. Instead, they can grow large, slow, and resilient. These are the ideal conditions for gigantic creatures to survive and thrive. Warm-blooded animals in Bergmann's rule. However, not all creatures are affected in this way. Polar gigantism primarily occurs in cold-blooded animals, creatures that rely on the environment to regulate their body temperature. Warm-blooded animals like polar bears or penguins cannot develop in the same way because they must expend energy to stay warm. Nevertheless, they still tend to be larger in cold regions, according to Bergmann's rule, because a large body helps retain heat better. But their size is still limited by the available food supply, preventing them from reaching the gigantic proportions of cold-blooded creatures. Exceptions. Dwarfism. Although the majority of creatures become gigantic, there are still exceptions. Some fish species in Antarctica evolve in the opposite direction, becoming smaller. This happens because food is not available year-round, and having a small size helps them mature faster, reproduce earlier, and survive better during periods of scarcity. This is a different evolutionary strategy, proving that there is no single rule that applies to all creatures. Slow evolution. One of the strangest things about this environment is the rate of evolution. Due to the low temperatures, all biological reactions slow down, meaning a single generation can last for decades. This makes evolution occur extremely slowly, and many species have remained virtually unchanged for millions of years. They become living fossils, retaining their characteristics from ancient times. The threat. But that very stability is also their greatest weakness. When the environment begins to change, especially as temperatures rise and oxygen levels drop, gigantic bodies become a burden. These species are starting to face difficulties in surviving. In fact, their sizes have been recorded as shrinking in areas where the water is warming. This shows that this ecosystem is extremely fragile in the face of climate change. The gigantic creatures beneath the Antarctic ice are not only the result of a bizarre evolutionary phenomenon, but also a testament to the fragile balance of nature. Just a small change could cause the entire ecosystem to collapse. Freezing the ocean does not kill life. It only makes life more gigantic. If you found this story interesting, please subscribe to the channel and hit like to discover more incredible mysteries of the natural world.